Hey everyone, welcome to lesson 4.03. Today we're going to be talking about multiplying and dividing radical expressions. Last time we talked about how to add radical expressions, and that was just a result of combining like terms. And recognize that a radical is just a like term with another radical who has the same, what's called radicand, the same value inside the radical. So we're going to take it one step further and we're going to multiply and divide. Well, before we do that, we're going to do a little experimentation to see what it means to multiply and what we get when we multiply some of these things in different ways. So in this case, let's say we're going to fill out this table, and I'll go over a couple examples with you, and then you guys can do the other ones. Let's say, where's my button? Okay, let's say that A is 4 and 9 and B is 9, and we plug those values into this expression and we plug them into this expression, and let's see what we get. If I plug 4 into A and 9 into B, I would get the square root of 4 times the square root of 9. Well, we know what the square root of 4 is. The square root of 4 is 2, and the square root of 9 is 3. So 2 times 3, when we simplify that, is 6. Now, if I were to plug those same values in, the 4 and the 9, into this expression, radical A times B, where A and B are both inside the same radical, let's see what we get. Well, we would end up with the square root of 4 times 9, and 4 times 9 is 36. And then the square root of 36, what number multiplies by itself to give you 36? That is 6. Okay? So we can see that in this case, whether you take the square root of each one separately and then multiply, or if you multiply them together and then square root, we get the same result. Let's see if that's true throughout the entirety of all of these. I'll do the next one with you. The square root of 100 times the square root of 25. Well, the square root of 100 is 10, and the square root of 5 is 5. So we'd end up with 10 times 5, which is 50. And then if I plug in the 100 times the 25 into the single square root, we get 100 times 25, which is 2,500. Now, we can go through a long practice of square rooting this, doing the prison break thing. We recognize that the square root of 25 is 5 times 5 times, 5 times 5 times 2 times 2. If I were to factor that out prime, that's what I would get. Okay, then we circle our pairs. We got a group of 5s, another pair of 5s, another pair of 2s. So we'd end up with 5 outside, another 5 outside, and a 2 outside. And notice there's nothing left inside the radical, so therefore we don't need a radical expression. So now we simplify. 5 times 5 is 25, times 2 is 50. So we can see the square root of 2,500 is 50. Oh, there it is. The same thing either way. You go ahead and simplify the other ones, and let's see if this shows true in all these cases. Now, when you get to the 3 and the 5 and the 7 and the 8, you're going to have to use your calculator to figure out what the square root of 3 is and what the square root of 5 is to make it easier for you. All right, now that you have done this, the square root of 9 is 3 and the square root of 16 is 4, so we get 3 times 4, which is 12. And then if I were to multiply those together first, 9 times 16 is 144, and the square root of 144 is 12. So far it works. So far we see, at least when we have nice clean square roots, the result of square rooting each separately and then multiplying is the same as multiplying the numbers together and then square rooting. Well, for the next one, if I were to plug in the 3 and the 5 into each individual square root, the square root of 3 is approximately 1.73, and the square root of 5 is approximately 2.24. Now, if I were to write out all of those numbers, not just 1.73, but the whole set of digits that your calculator shows, and multiply it by all the digits for the square root of 5, we would end up with 3.87-ish if I round it to the nearest hundredth. Now, if I multiply those together first, I get 15, and then the square root of 15 is in fact 3.87-ish around, right? So we can see that it works there as well. For the last one, the square root of 7 is going to be 2.65 about, and the square root of 8 is 2.83 about. So when we multiply those together, we end up with 7.48. If I multiply those together first, the numbers first, 7 times 8 is 56. And the square root of 56 is going to be 7.48. So you can see that this rule works in all of these cases. So the rule says this, that the square root of A times the square root of B is equal to the square root of A times B. Well, what does that mean? That means pretty simple. Let's look at an example of this. Where A and B are both positive. We'll talk about when A and B are negative later on. All right, so let's look at an example. We want to simplify the following. So for A, it says, what is the 3 square root of 6 times 4 square root of 5? Now, these parentheses are just a fancy way of saying multiplication. And so we could rewrite this as 3 square root of 6 times 4 square root of 5. Now, from the previous lesson, these are not like terms because they're not the same radical. They're not the same radicand. The numbers inside don't match. But we're not trying to add these, we're trying to multiply them together. And so this would be the same as saying, what's 3x times 4y? Well, we can't multiply the x and y and simplify this, but we can rearrange this to say 3 times 4 times x times y. And then we can simplify the 3 times 4. Well, we can do the same thing here. Let's rearrange this so all the numbers that are outside the radical are next to each other. So it'd be 3 times 4. And all the numbers inside the radicals are next to each other. So it'd be radical 6 times radical 5. That will produce the same result. And then 3 times 4 we know is 12. And then based on what we just talked about, that the square root of A times the square root of B is the same as the square root of A times B, well, what does that mean? That means that in this case where I have the square root of 6 times the square root of 5, that's going to be, let me write that down here, square root of 6 times the square root of 5, that's going to be the square root of 6 times 5, which is the square root of 30. And so now this is a lot easier to look at, a lot simpler to see. The only other thing we want to make sure is that it is as simplified as possible. Is the radical simplified? I should make this screen bigger so you can see it a little better. And the way we would do that is we would factor out the 30. So doing the factor tree for 30, you end up with 2 times 15, 2 is prime. 15 is 3 times 5, and both of those are prime. So we end up with the square root of 2 times 3 times 5, and then the 12 is out front. Notice there are no pairs there. There are no partners to try and escape the prison. So we can't try to escape the prison. We leave them all inside. And so this is our most simplified form, 12 radical 30. So you go through the process, you try and simplify it as much as you can. If you can't simplify anymore, then you leave it like that, 12 radical 30. All right, let's go ahead and take a look at another example. We've got 2 radical 10 times 3 radical 6. So B is, move my paper up here, 2 radical 10 times 3 radical 6. So we can rearrange those so that I'll say 2 times 3 times radical 10 times radical 6. 2 times 3 is 6, and we can multiply these together now and leave them inside the radical, so it'd be radical 60. From here, we try and simplify the radical 60, so I'll do the cake method this time. So 60, a factor of 60 is 2. 30 is left over. Factor of 30 is 2. We have 15. And then the factor of 15 is 3. We're left with 5. And factor of 5 is 5, so we're left with 1. And so our factors are 2 times 2 times 3 times 5. And so now we can see that we do in fact have a pair of 2's, so we can take that out. So it'll be 2 outside, and then radical 3 times 5 inside. And then we still have the 6 out front, so we're going to keep that there, 6 times whatever this simplified to. So now we can multiply the 6 and the 2, and we end up with 12. When we multiply the 3 and the 5, and we end up with 15. That is the simplest radical form. All right? So let's double check my answers and make sure I am correct. We get 12 rad 30 on the first one and 12 rad 15 for the second one, so that's good. Now it is your turn. So go ahead and pause the video and you try these 2 problems. And when you're done, come back and look at how you did compared to my answer so you can make sure you know what you're doing. All right, for number 1, we have 4 radical 12 times 5 radical 18. Well, rearranging these, you get 4 times 5 times radical 12 times radical 18. Well, 4 times 5 is 20. Now, radical 12 times radical 18. 12 times 18 is a pretty big number. Maybe we get our calculator out for that, but really we don't have to. I'm going to go ahead and multiply it just so you can see. 12 times 18, 6, carry the 1, that's 9, 0, 2, 1, 6, 1, 216. So we get the square root of 216 here. Now from here, though, we want to factor this down and look for pairs so that we can simplify this radical. And now we can do the factoring tree, we can do the cake method. I would argue that the factoring tree is actually going to be more beneficial in this case. So if I'm going to take 216 and factor it down, what are 2 numbers that multiply to 216, you might ask? Well, obviously 2 works. But where did we get the 216 to start with? We got it from multiplying 12 times 18, which means 12 and 18 are both factors of 216. So we can write that down, 12 times 18. Look at that. And then from here, we can factor each one of these down. 12 factors to 3 times 4, and 3 is prime. 4 factors to 2 times 2, and both of those are prime, so I'm going to circle those. Those are like the fruit at the bottom, at the end of the branch of the tree. And then 18 factors to, well, that's 2 times 9, let's say. 2 is prime. And then 9 factors to 3 times 3, and both 3 and 3 are prime. So our prime factors here are, we've got 1, 2, 3 2s. Oops, if I could write that. 3 2s. And we have 3 3s. And so that's all inside the radical, and the 20 is still outside there. And then from here, we can see that we have a pair of 2s and a pair of 3s. So those are going to go out. Remember, one gets crossed out from each pair, and the other one escapes, so we end up with 2 times 3 on the outside. And then left over on the inside is the 2 times 3 that weren't circled. And then we still have that 20 out front. So now we can just simplify this. 20 times 2 is 40. Times 3 is 120, and then 2 times 3 is 6. So we end up with 120 radical 6, and that is correct. So we know we're on the right path. All right, for the next one, number 2. Number 2, we have the 3 radical 5 times 2 radical 15. Now I'm going to shortcut this just a little bit. Instead of rewriting it so it says 3 times 2 times 5 times rad 5 times rad 15, I'm just going to multiply the 3 times the 2. 3 times 2 is 6. And then rad 5 times rad 15, well, that's rad 75. Okay? Now we want to simplify the radical, so we do our factor tree. Well, what are 2 numbers that multiply to 75? Well, the 5 and the 15 made 75, so we can just use those. So 5 times 15. 5 is prime. 15 factors to 3 times 5, and both of those are prime. So our factors are 3, 5, and 5. So we get 6 square root of 3 times 5 times 5. We have a pair of 5s there now. So those can go out. So we have 5 outside, radical 3 inside, and we still have that 6 left over from the beginning. So 6 times 5 is 30, and then radical 3. And that is our simplified form for number 2. And we did it right. All right, let's go ahead and take a look at division now. Now, here's something that's very interesting, and maybe a better way or a quicker way of remembering these things. When you're multiplying radicals together, you multiply the numbers that are outside the radical together, and then you multiply the numbers that are inside the radicals together, right? So you multiply the outsides with the outsides and multiply the insides with the insides. That's how you multiply radicals. Well, when you're dividing radicals, you do the same thing. You're going to divide the outside numbers, the numbers that are not inside radicals, and then you divide the inside numbers. Now, when we're dividing, oftentimes we're talking about fractions. And I know everybody hates fractions, but let's do a quick review of simplifying a fraction. If I were to say 10 over 15, that really means that's the same as saying 10 divided by 15. Now that doesn't go in evenly. It's not going to be a nice whole number. So what we do instead is we reduce the fraction. So what is a common factor out of 10 and 15? Now we can go through and do our factor trees if we need to, but 10 factors to 2 times 5 and 15 factors to 3 times 5. We can see then that the 5s end up reducing, and so our end result is going to be 2/3. Okay, that is the simplified form of that fraction. Now, if you wanted to look at it a little bit differently, you got 10 over 15. What you could recognize is that, see how the 5s reduce here? We could divide both the top and the bottom by a common factor. So we're reducing it by a common factor. They both divide by 5. So 10 divided by 5 is 2, and 15 divided by 5 is 3. So we get the same thing. So that's a quick review of simplifying fractions, because that's what we're going to be doing here with the radicals. So here's an example of this. We're going to simplify each of these expressions. So for A, we have 2 radical 10 over 3 radical 2. Now, notice what it says here. We are going to divide the outside numbers with the outside numbers and the inside numbers with the inside numbers. So we can see that the 2 and the 3 are both outside. So I'm going to put those together as one fraction. And then the other fraction is going to be the radical 10 divided by the radical 2. And we'll put a multiplication sign in between. This means the same thing. 2 rad 10 over 3 rad 2 is the same as 2/3 times rad 10 over rad 2. Now the 2/3 can't be reduced. Those are both prime, so that's going to stay exactly how that is. That's 2/3. The radical 10 divided by the radical 2, well, we notice that the 10 and the 2 can both be reduced. We could divide both of those by 2. And so we end up with the square root of 5 on top and the square root of 1 on the bottom. Now the square root of 5, I don't know. That's as simple as it gets. I could simplify, or I could estimate it. It's going to be approximately 2 point something. But I'm going to leave it in radical form, radical 5 there. Okay, right? Got the square root of 5 on top. What's the square root of 1? Well, the square root of 1 is just 1. So we can just write that as 1. And then we can simplify this by saying we have 2 square root of 5 on top, multiply straight across, over 3 times 1 is 3. So we get 2 radical 5 over 3. Okay? All right, let's take a look at B now. B, we have, let's see, 8 radical 24 over 2 radical 3. Now, we could recognize that the square root of 24 could be reduced. It could be simplified. And if you want to do that first, that's fine as well. And in fact, I'll show you how to do that in a separate method. Let me rewrite this so I got a cleaner sheet of paper here. Okay, using the method I just showed you, though, we separate it so the outsides go into their own fraction, the insides go into their own fraction. Okay, 8 divided by 2 is 4, or 4 over 1 if you want. And then 24 divided by 3, those are both reducible by 3. And so 24 divided by 3 is 8, so we end up with radical 8. And then radical 3 divided by 3 is radical 1. And then from here, the square root of 1 is just 1. So we have radical 8 over 1. And then multiply straight over, we end up with 4 radical 8s all over 1, which is just 4 radical 8s. But the 8 can be reduced, right? We can simplify that radical by factoring it out. 8 is 2 times 2 times 2. And then we can circle our pairs here. And we end up with, let's see, one of those goes out and the other one disappears. So we end up with 2 radical 2 with this 4 out front. And so our final answer is going to be 8 radical 2. Now, that is one method to solve this. That's a lot of work there. And if that's what we have to do, that's what we have to do. But let me show you a different, maybe quicker method. I don't know if it's quicker or not. It's just a different method. That 24, we can simplify that radical. 24 factors to 2 times 12, 2 is prime, 2 times 6, 2 is prime, and 2 times 3 2 and 3 are both prime. So the top becomes 8 radical 2 times 2 times 2 times 3 all over 2 radical 3. And so from here, we see that we have a pair of 2's that can go out. So outside on the top, we end up with 2 square root of 2 times 3. And then we still have that 8 out front, all over 2 radical 3. Now from here, we can see that the 2 on top and the 2 on the bottom are going to reduce. And because the 3 is inside the radical and the other 3 is inside the radical, those reduce. And so we end up with, on top, we end up with 8 radical 2. And on the bottom, all those numbers reduce, so really it would just be over 1. And so our final answer is 8 radical 2. And so that was the same as before. It's just a little bit smaller steps. If you feel more comfortable with that, that's fine. All right, so let's take a look at 3 more practice problems. You guys go ahead and do these, and then come back and see how you did. All right, for number 3, we have 10 radical 54 over 2 radical 2. Now, I'm going to separate this. So it says 10 over 2 times radical 54 over radical 2. The 10 and the 10 divided by 2 reduces to 5 over 1. And then the radical 54 and the radical 2, both of those are divisible by 2. So we end up with radical 27 over radical 1. And then I'm going to do a couple steps all at once. 27 factors to 3 times 9, and then 3 times 3. So we have 5 over 1 times radical 3 times 3 times 3 all over, and the square root of 1 is just 1. Circle our pairs here. So on the outside, we end up with 3. Inside, we end up with 3, and then over 1. And now we can multiply those straight over. 5 times 3, those are outside, so that's 15 radical 3 over 1. Oops. And then we can just say it's 15 radical 3. And that is our final answer for number 3. All right. Number 4, we have 12 radical 75 over 3 radical 3. So here's what I'm going to do just to quicken this up a little bit. The outsides both reduce. I could reduce the 12 by 3 in the same way that I could reduce the 3 by 3. So when I divide both of those by 3, I get 4 over 1. And then for the 75 and the 3, I do know that 75 is divisible by 3, because if I add 7 plus 5, I get 12, and 12 is divisible by 3. And so we'd end up with 75 divided by 3. If you think quarters, that's going to be the square root of 25 there, over the square root of 1. And then we know the square root of 25. The square root of 25 is 5. And then the square root of 1 is 1. So we end up with 20 over 1, or just 20 as a final answer. All right. And the last problem, number 5, says 16 radical 8 all over 8 radical 4. Well, the 16 and the 8 reduce. They both are divisible by 8. So we'll divide the 16 here by 8 and the 8 here by 8. We end up with 2 over 1. And the 8 and the 4 have a common factor of 4, so we'll divide each of those by 4. And so we end up with the square root of 2 over the square root of 1. Now the square root of 1 is just 1, so we have 2 over 1 times radical 2 over 1. And so that becomes 2 radical 2 over 1, which is 2 radical 2. So that is how you divide radicals. All right, so that wraps up the lesson. Hopefully you have, you're starting to understand how all this radical stuff goes together. Simplifying radicals, you can see from lesson 1, rolls into every lesson from here until quite a while for the next few units. Okay, if you have any questions, please comment below. Otherwise, ask me on our next Zoom meeting or tutoring session, and I will talk to you all later.